Hi class, we are going to talk about section 3.7 and 3.8 in this video, some of which we've already talked about in class. So I'd like for you to open up Sketchpad and we are going to make our triangle. And I want you to make perpendicular bisectors of each side. So construct the segments and then construct the midpoints of each segment. If you highlight a midpoint and the segment and then construct a perpendicular line, it will be the perpendicular bisector. And so we want to construct all three of those. Notice they do intersect in one point. So the intersection point of perpendicular bisectors is called the circumcenter. Oops. So we have triangle ABC with circumcenter D. No matter how I move the points around, we still have a point of concurrency. It may not always be on the interior of the triangle, but they will always intersect. Okay, so you will want to put a snapshot of this in your notebook. Make sure that you call these line segments perpendicular bisectors. Okay, take a snapshot and put it in your notes. And we are going to fill in the conjecture. Perpendicular bisector concurrency conjecture is perpendicular bisectors are concurrent, and their point of concurrency is called the circumcenter. Okay, so now you can see the next conjecture is about altitudes. So if we go back to our triangle, and let's just hide these lines, our perpendicular bisectors. We could hide the midpoints as well. I'm going to leave point D as the circumcenter. And I will make that note so that we remember. Okay, so now I want to make altitudes. If I highlight a vertex in the side opposite, it will make an altitude. Remember that if your triangle is obtuse, it may be on the outside of the triangle. Look again, they are concurrent. If I make it a right triangle, you can see the altitudes are the sides. If I make it obtuse, they intersect outside of the triangle. So I'm going to keep this on the inside. I am going to call the intersection point point A, or point E, sorry. Okay, and this point is going to be called the orthocenter. It is formed by the altitudes of the triangle. So I'm going to put perpendicular bisectors over here with circumcenter, so we remember that those go together, and then point E is the orthocenter formed by altitudes. So I would take a snapshot of this and put it in your notes, and we are going to finish those, writing those conjectures there. The altitude concurrency conjecture. The altitudes of a triangle are concurrent. Their point of concurrency is called the orthocenter. Okay, so make sure you put me on pause and take the time to get all of that into your notes, and I would attach our picture to go along with it. The circumcenter conjecture is the circumcenter is equidistant from the vertices. So we're going to go back to our picture. Point D is our circumcenter, and we have done this before where we made a circle. So you can see if we connect, make the radii the length of CD or CA or CB, you can see that D would be the center of our circle. Okay, so that is going to be this conjecture. The circumcenter of a triangle is equidistant from the three vertices. And then the in-center conjecture, if you remember with this one, we inscribed a circle, and so this in-center of a triangle is equidistant from the three sides of a triangle. Okay, we're going to do one more construction today. There's a picture of the inscribed circle and the circumscribed circle. Okay, we're going to do one more conjecture. In construction, we are going to construct the medians. Remember, a median goes from the vertex to the midpoint of the side opposite. So on our triangle, I am going to hide some of these objects. I still have the orthocenter and the circumcenter showing. I am going to bring the midpoints back up. And then I'm going to construct the median. So from the vertex to the midpoint of the side opposite, are the medians. Again, they are concurrent points. This point is called the centroid. Let's give it a name. The computer's going to call it F. That's just fine with me. So, point F is the point of concurrency of the three medians of the triangle, and it is called the centroid. Okay, so I would take a picture of that. Notice I have all three of these points on the interior of my triangle. Point E and D can be on the outside. F remains on the inside. If I put the in-center back in here, the angle bisectors, which I think I will do, so let me... Thank you, Mr. Thompson. I'm going to hide the medians. And I am going to make the in-center. So I'm going to bisect my angles. Uh-oh, I hit point A. Uh-oh. Oh, well. Okay, so I am going to bisect my angles. And put the in-center on this picture as well. So point G is my in-center. You will want to save this picture because we will refer back to it. And there are all your points of concurrency. There they are on the interior. See if you can make them all a one point. Look at that. Good stuff. Okay, so take a picture, put it in your notes. Let's finish our conjectures. The median concurrent conjecture. The three medians of a triangle are concurrent. Their point of concurrency is the centroid. the centroid conjecture. The centroid is the center of gravity. And we're going to talk about this more in class. Okay, we'll see you tomorrow.